Okay, here is my Python PostScript interpreter for CS322. Let's quickly dive in to show all these features. Should go into CS322. No, we're already in there. Okay, perfect. So we can begin this program with static or dynamic mode. This is the command to run it. Let's begin with dynamic mode, right? And dynamic scoping, if you don't remember, is where the function is actually called. Whatever environment that is, the local variables in that environment are going to be used for the computation. Whereas for static scoping, right, which is like things like Python and stuff, it will use the local environment from where the function was defined, right? So this is very different from like PostScript or the shell command prompt. So let's begin by making a function. Not a function, a variable x. Let's make it 10. We're going to define it. And then let's begin. So we're in dynamic mode. So let's make a function f. What should f do? X 5. Well, so it takes a x and it multiplies it by 5. We'll define that as well. So now let's go into a local scope, and we can do that by, very similarly in PostScript, creating a dictionary. In this case, it's going to be of size 3, and then we are going to insert ourselves in that local scope. Now, let's create another x, something crazy. Let's make it 100. I should not have done that because, see, this is one whole line, and my interpreter is going to go line by line. So since I equaled, let's see if that actually disappeared. So let's define x as 100 here. So we have two x's, the global x and the local x, right? Now, if there's a static scoping, this f would work with this x, right? Because this is where it was defined. However, this is dynamic scoping, and we called f. Well, we didn't call it yet, but we just called it now in our local scope, which means it's going to use the local x, right? So we can see that this is going to equal 500. Now, we can go ahead and quit our interpreter, and let's go into static scoping. All right, and let's insert the exact same sequence to show what's up here. Creating an x with 10. F is going to, let's just do the exact same thing. So we know that there's no differences attributed to whatever is happening. Dict of 3, let's begin. So we have global environment x and our global function f. Now what we did here, begin, and then let's go ahead and define x as 100, and then we just call f, and then this is going to now equal 50, right? Because we're in static scoping, it was defined in the global scope, so it's going to defer to the x in the global scope. That's all fine and dandy. Some other computations we can show. Let's see what Subu had on his list. Okay, so basic arithmetic, right? I kind of showed it here, but I guess we can show the full scale of it, since this video has to be 5 minutes. 10 to add, right, is 12. We already know that. Multiplication, we saw that. Have division, sorry, I don't know. Let me do 2 and then divide equals 12. Alright, see, I did 2 and then straight equals, so that's where that came from. Confused me a little bit. Also have mod 25, 13. Mod is going to be 12. So that's, I think, pretty good for the arithmetic. I think that shows it. Control flow. Let's true, like a simple, just like true. If it's true, let's put 999 right in this code block here. And then if. So if true, we print 99, right? False. That should not have happened. Oh, that's why. I am bad at typing and it's late, so, it is what it is. Equals, boom, boom, boom. Alright, if we get nothing, right, because it's false. Let's combine these guys. Let's make sure our thing is empty. Good. So false. Let's do a code block of 1, code block block of 2, right? And then if we do if else, essentially it's going to say, all right, if this is true, we do code block 1, and if else, we do code block 2, right? And we're passing it false, so it's going to do code block 2. So if you pass this in and do equals, we get 2. That is all fine and dandy. What else do we have for control flow for statements and loops? All right, so let's start at 1. Let's go increments of 1, and let's do it 3 times. And we are going to duplicate this, and then we can do the for loop, right? And so this is going to start at 1, increment by 1 for 3 times, where we're going to get 1, 2, 3. So that's fine. We can also do this for strings if you wanted to. We could do like you represent strings with these parentheses, and then you can just print it. You know, it's gonna repeat hi, right? And we have no new lines, right? So that makes sense. Okay, I just realized I have to show a couple other things, so I ended a little prematurely. Let's go ahead and get into our interpreter, and let's show like these and things, right? So true, false, and is obviously false. True, false, or is true. Nice. And then we also have string operations. I mentioned before that we represent these kind of things as strings with our parsers of parentheses. So we can find the string like this. It's going to equal 12, 11. Okay, I counted a little too fast, but is what it is. Let's take this random string. Let's go for starting at index 2 from 0 indexing, so that's going to be the C. We're going to take the next 3 variables, and then we're going to call this will make sense. So CD, right? CD. Pretty cool. I think that's fairly good enough. One thing we can actually do is show absolute value, stuff like that. Yep, I got it all. 1.8 floor, that's going to be 1. 1.8 ceiling, is going to equal 2. 1.5 round is going to equal 2. So, you know, I think that gives a pretty good illustration as to my interpreter.